Wait. And we're live. Welcome to the 22nd, I think it's the 22nd, Decentralized Data Now. This show was made, actually, it originally started as the open source block explorer is now called, but we got an open source block explorer. So we figured, hey, we still have all these cool data-centric people. Let's start another show. And we're just continuing on. And so let's just pass it along. I'm Griff Green. I'm with Giveth. I'm just here to encourage this community because I think it's really important that we have access to data without going through central parties. I'll pass it to Alexi.
Hello, my name is Alex. I'm from Fluence. We're doing decentralized database cloud. It's my first time here, and I'm a backend developer mainly. That's it.
And then pass it to Alex.
Yeah, to Alex.
That's me. Okay. I was working on Remix with the Ethereum Foundation, and currently working on a new project called Play, also with the Ethereum Foundation. Mostly it's front-end stuff, and it's building dApps or tooling for developers. I mean, Remix is like this IDE in the browser, and we built something similar that is, yeah, we added it to the list so we can present it later. That's 30 seconds, I guess. So then I would pass it on to Thomas J.
How you doing? My name is Jay, Thomas J. Rush. You might have heard me called. I'm going to talk about QuickBlocks today, which is now renamed TrueBlocks. So we have an issue with names, but I'm happy to bring a user interface to my long-standing command line code. So I did it just for Nina. Who's next?
Yay! Hi, everyone. Yeah, I was working on Remix for the last 2.5 years, or maybe 2 years. And then for the last half a year, we're working on Play, basically trying to make Remix more lightweight and embeddable so that you can embed it in like blog posts or your pages as an iframe. And currently, we're trying to build a CodePen using this embeddable Remix or Play editor, and using big data of verified contracts to feed it in and present like tons of contracts that exist in the space in a nice, user-friendly way.
Oh, that's awesome. I can't wait to hear more about that. But let's start with Jay, man. I cannot wait to see a front end on TrueBlocks. I'm just curious to see how you pull it off.
I'll do my best.
Who worked on this with you?
Huh?
Who built this with you?
Yeah, I work with a fellow called Ed Mazarek. You'll see his name is Wild Molasses around. He's fantastic data guy, and everything he says I know is true, and I know should be true of my code, and he just puts his finger right on all the things that I'm doing wrong. So it's really helpful. So I guess I'll start. Can you see my screen here?
Yeah.
Okay, so I'm just going to try to give a little bit of context to what I built. So we all are running, we all know we're running Ethereum nodes against the internet. So what a blockchain explorer does fundamentally is it runs against the node and it extracts some data from the node. So Griff, your open source blockchain explorer group, in that group, we built a blockchain explorer that extracted the entire database from the Ethereum node. And the thing that I didn't think worked there was that what you've done now is you cannot run that explorer on a small machine like a laptop or a desktop. So my scraper only scrapes a very specific thing, which is just an index of addresses per transaction. And we build that index ongoing. And I'm going to show you our stack in a minute, but I'll just go forward here a little bit. So there's another piece of software that monitors. So once we have the index, now we can watch smart contracts and we can keep track of what's happening on specific smart contracts. So that's what this monitor piece does. And on top of the scraper, we also build an API to serve applications. So all of this code below the applications I've been working on for 2 years, and the last month or so I've finally gotten to build the first application. So the thing that's always bothered me is I think people think that when you're interacting with the blockchain, it's something like this, where you're interacting with both the internet and the blockchain. But what's really true is everybody's actually interacting with Infura or Etherscan or some other third-party blockchain explorer. And I don't think this is how the system can, ultimately, I don't think the system will work if this is how people interact with the chain. So what we want to do is build applications that the user interacts with, and those applications interact only with local software so that the whole stack is completely local. And the reason why this couldn't have been done before is because the Ethereum node is not a database. So by adding an index of addresses on top of the Ethereum node, we've effectively created a database that we can then serve through an API and then give it to your application. So I'm going to show you an example of that. But I just want to make another point. All of the interaction with the internet happens only through the Ethereum node. And what you get now, unlike here, where Infura and Etherscan are watching everything you do every time you go to their website, here the interaction is 100% private and you get access to every piece of data. And this to me is what a decentralized network is about. And then also, the data is completely trusted and no one can ever take the data away from you because you're running your own node. So every time I talk about this, people say, how can I run my own node? And luckily, we just got off a phone call with the DApp node guys who solved that problem for me fantastically because they're helping people run their own nodes. And Griff, you know about these guys as well. So is everybody hearing me?
Yeah, we're all just muted.
Okay, so now I'll just show you an example of an application that we built on top of this stack. So we call it, this is actually built in a piece of software called FileMaker Pro because I wanted to, first of all, I don't know how to build front ends except in FileMaker Pro. But secondly, I wanted to point out that because the entire stack is local, you really don't have to build applications in a browser anymore. But I won't make that point too strongly. But so this application, the basic idea is I want to study a smart contract so that I understand it to the point where I can do accounting, for example. So I'm going to use the Giveth donation contract as the example. And what I can do is I can add it to the monitored list. So now it's one of my monitored software. And this is the API that is delivering the data to this application. So now what happened here is we're running a node over here. We're running a data API here, and we're running the application, which is consuming data directly from the node. So we went out and we scraped 618 transactions, and we can label the functions in those transactions. And my goal is to understand what happened on this contract. So I can categorize these transactions. So this one, for example, is an invocation of a contract. This one's an invocation of a contract. That's tedious, so there's a button here that we can just search through things that are clearly invocations of a contract and just mark them. So I just marked all of those transactions. And then this one's a token invocation because I can see that it was a transfer function. And now what I want to do is hide all of these transactions that I've already identified, because my goal is to identify every one of them. So another thing that we can notice is that this is a donations contract, and incoming ether that comes directly into the thing without a function is a deposit into the contract. So I'm going to label this as a donation. So I can see that all of these are what appear to be donations. And now I'm going to hide those things. So now I still have, out of the 600, I have 189 to identify. I'm going to switch to a different contract just because there's less transactions and I can identify them all easily. So I'm going to add another monitor for the White Hat Group's donation. And you can see it's a little slower than a web page, but that's because I'm extracting data at this time from the node. But now that I've extracted it, now it's as fast as a web page. So I can mark all these calls that I know about, I can hide them, and then I can mark the donations and hide them. And now I have only 7 transactions that I don't know about. But now let's say I can notice that this address here, this 05F, is pretty frequent. So I'm going to go and look at the details of this address. So this view lets me see the events that were generated on that address. So here was an event called address change. And this view lets me see the traces that were generated on that address. And then I can try to get the ABI for this function. So now I can see that this transaction was a call to a function or a smart contract that set the address and then called owner or something. So what I'm trying to point out is that I don't know anything about these smart contracts other than I have the names of the functions and the names of the addresses. And I'm starting to get a pretty good idea of what's going on with this contract. So now I can go in here and I can look at the trace view. I can grab the traces. You can see that the API grabbed the traces. And then I can articulate it. And that's a confirmation of some kind with a controller that does a proxy payment and generates tokens. So I don't have the source code. All I have is the ABI. And I'm really starting to get a feel sort of for what's happening on this contract. Then I can look at the events. There was an event called a confirmation, a transfer, a multi-transact, whatever that means. As an insider to this smart contract, I probably know exactly what it means. As an outsider who's interested in what's happening on the smart contract, I don't know exactly what it means, but I'm starting to get an idea. I'm going to come back over here. Mark all the calls, and now you can see that we have all the cards are marked. So now I'm going to show everything. And now I'm basically ready to do accounting. So I'm going to export to a spreadsheet. And this it's not quite true to say that it has everything you need for accounting, but it's really close. There's only a couple pieces of information missing, in particular, like traces and stuff like that. But I could give this to my accountant and he could account for these 77 transactions on the White Hat Group's donation address. And now I just want to show you what Ed Mazarek does. So he is really familiar with this program called R, which is a data analysis program. And just like I can export to Excel, I can export out to R, and then that creates some nice charts that show the different amounts that were deposited over time, the different people who sent donations to the contract. We can break out the function calls by type, and we can break it out by person. If it's okay, I'm going to do one more real quick one, just on the Moloch DAO, because this is actually pretty interesting. So this is going over the data API, is like grabbing the data. You can see it grab the data there. And you can see it's a little bit slow, but that's the price you pay when you have to get the data from the node, because the node doesn't really deliver the data as fast as you would like it. But having said that, without QuickBlocks, this same activity, which is to extract just the 1,062 transactions from Moloch DAO, and I'm not exaggerating, would take 30 days as opposed to 30 seconds. So you have to kind of make your trade-offs.
And that's because you've indexed you've already known that you were like watching these addresses. And so you indexed this locally.
Well, we index every address that ever appears anywhere on the chain. And that lets us scan, 100,000 times faster than the scan would take if we had to look at every transaction. So I don't know beforehand that I was going to use Moloch DAO. I was lucky because I had an index of every address, and then I can scan that in about 30 seconds. And then once you have a list of transactions, extracting specific transactions very fast, actually. Even though it's not as fast as I'd like it to be, it's fast enough that it's usable. So now, but now that monitor piece, I showed you a piece called the monitor piece. What that thing does is once I scrape an address, now that will constantly keep the address up to date. So I won't have to do another, the next time I try to get data, it'll be much faster because it will have been already extracted.
One question, Jay. Do you, like when you say that you index everything, does that mean that you run a node and that indexes, and then because the node is running in the background, you can then kind of get the data very fast? Is this like a workflow?
In my world, you have to run a node. I think that these blockchain systems ultimately will fail if people aren't running nodes.
Yeah, makes sense.
I know it's a burden, but it doesn't really matter if it's a burden, because if the only way to get data is to rely on someone else to give it to you, the system isn't decentralized, and it's just not, we're not going to be able to build what we think we're going to be able to build.
Yeah, and you don't necessarily need to run, not every individual needs to run a node. I mean, this is where a DApp node comes in, where it's like, at least you know who you're trusting if you choose to.
Yes, that's right. That's right. I think that it doesn't have to be the case that everyone runs a node, but what has to be true is that everyone that wants to get direct access to the data without a third party has to be able to do that if they want to.
Yeah.
Because those are the people that are going to bring the trust to the rest of the people that don't get the data.
Do you have to run a full node, or can ETH node be enough?
Yeah, currently we only run against a tracing node, but running against a full node or running against a light node will, I don't know about a light node, but a full node, we can run that way, but we wouldn't get as many entries into our index. So you wouldn't get as deep a view into your smart contract. And it turns out that about half of all the interesting stuff happens in a trace. So if you're not running a tracing node, you can get some information, but you're not going to be able to get, down to the penny accounting information. So I kind of started with the more difficult problem, because then I can back off onto an easier problem. So you can run it against a full node, but if you do, you're not going to have accounting quality data, because money transfers under the covers, actually.
Can this process, like, I'm just like brainstorm, I mean, I don't know this low level stuff so hardcore, so now I'm just getting questions. I mean, is it okay to ask you?
I'm so happy to hear questions.
Cool. No, I'm just thinking, can this be like a shared effort, like a decentralized process of indexing? And like, can this be even split? Like if I'm running an indexing and then Alex is doing this and you, and we kind of like together do this?
Absolutely. That's exactly what I want to work towards, because see, I've built this piece here, this indexing piece. So my biggest concern for the last year is, how do I share this piece of information without becoming just like Etherscan? So I've been thinking about that a lot, and I think it has something to do with IPFS. And what I'd like to try to work on is do this extraction and then share it back out to IPFS. And what I'm hoping happens is because my list of interesting addresses is different than your list of interesting addresses. I don't really need to hold the parts of the index that you care about. You can hold that part of the index.
Exactly.
I can hold my part of the index.
Yeah.
And then what else happens is people like CryptoKitties who have about, I don't know how much of the index they are, but they're a significant percentage of the whole index is CryptoKitties. If they want to scrape and hold their own portion of the index, they're actually holding their fair share of the index. And because I've only done 2,000 transactions, I'm holding my fair share of the index. So if we can do that, if we can actually share this index across the community, everybody would be holding their own share naturally. And I think I'd love to see that happen. So yes, I don't want to become the person that holds the index. I want to become the person that shares the index. So this is the Moloch DAO, and I have all the transactions identified. So now I'm just going to export out and see what we see here.
Okay.
Go ahead.
All right. If there is already like a proposal for this IPFS architecture, how do you want to share this? We would be interested because we have a similar problem for a project that we're currently working on.
Yeah, you mentioned like smart contracts.
Yeah. I mean, Etherscan gives you the solidity contract for some addresses.
Verified.
Yeah, right. And we can scrape them or get them from somewhere else and then store them. But if we run an open source server and they store all the contracts and you can run one, everybody needs to start again from scratch if they can't share the database. And we have some ideas and we're working on this, but it feels like a similar problem.
So if you look at what I was doing this is exactly the same problem, I think, because look what I'm doing. I'm naming addresses. I'm putting a name against an address, or I'm putting this is a little bit different because the function there's no chance of it being any other name. But this piece of information, the name of this contract, should be shared across the whole community as well. And so should the index, and so should the source code, and so should the ABI files. So there's a whole class of information that, if it was shared, would help everybody understand everybody else's smart contract.
And have you guys talked to BlockScout at all about that? Because
absolutely.
Yeah, we're talking to them.
Yeah.
No, but I'd love an introduction, Griff.
You know BlockScout. But yeah.
Wait, what's BlockScout? Is that POA?
Yeah, it's POA.
Oh yeah, no, I know those guys. Yeah.
What we figured out, like if you store things on IPFS, you cannot easily update the IPFS file. I mean, you kind of like have to use IPNS and then kind of always switch the pointers. A new document, but there is another technology, and we will maybe try this thing out, and it's called DAT, D-A-T, DAT project, and they basically build a Git version-controlled file sharing system. So we were thinking to actually, like first one who starts scraping pushes to that DAT, D-A-T file, and then everyone else can like update the same one because it's actually kind of like a shared file system, and you can update always the same file.
That's really interesting.
We tried to build like a little prototype and see how it goes. Maybe it won't work. We have an idea how we could approach it, but we'll see.
Yeah, so my data is a little bit different because your data is the source code for smart contracts and developers are changing it constantly. My data is on-chain data. So once it's on the chain, it never changes. So I have a little bit less of I don't really have that problem where the data changes. So like my data is frozen solid once it becomes, 5 minutes old on the blockchain.
Ours is also frozen. I mean, we want to, in the sense of that once it's verified, like I get the
Yeah.
bytecode of the contract and I have a smart contract, I compile it and compare if the bytecode checks out, then this is the thing, the source code for that contract, and that should never change.
Yeah, you're right, actually. And you know what? If that was available, I would build it into my tool, because I do have a little button here that when you go here, 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 you can click on this button, and it's supposed to open the guy's source code, but it's broken now because I don't have any source code. So.
This is what we try to work on. Let's see if we manage. I don't know. I hope.
So this is what I'm building.
Looks amazing. I mean, like I remember you showing us this like 2 years ago or something, and it was just running in terminal. And of course, because we're front-end people, is like, yeah, I can see the browser finally.
Yeah, I'm really excited about the ability to build a dApp off of this, and like a real dApp. I mean, because we don't have real dApps. You know, it's very rare that some. I mean, if you have a real dApp, it's horrible. Like it's.
I know, Griff. It's basically a development environment, really.
Yeah, that's what it looks like.
Like right here, so these applications right here, they can be right now, they're only communicating one way from the Ethereum node up through the data into the application, but they can communicate back down into the node.
Yeah, I'm really excited for the ability to do this with a dApp node, you know, because that's the problem is that, okay, so now you can build a real dApp, but, you know, you have to be connected to somebody's node to do it. So, like, if, you know, then either the user has to dedicate a computer and set up their own environment, or they can, I guess they can still kind of connect to Infura.
Yeah, this node here can be anywhere.
Yeah.
The trouble with Infura is they don't give me a tracing node.
Oh.
So, I mean, I don't know if they may do it now. I don't think they did it when I was looking at it, but.
Probably not.
Can you, when you say that node can be anywhere, can it be in the browser?
Well,
it can be anywhere. You know, I kind of purposefully went all the way to the end of, you know, make it completely local just to see what it would look like. And now I can back off from that and put the, you know, different pieces anywhere they want to be for the convenience of the user. But I wanted to build the system in a way that was able to go all the way down to the root of the problem first, and then back off if I had to, if that makes any sense at all.
Let me just say, I don't think you can put a node in the browser. Can you put a node in the browser?
I wouldn't, but I don't like to put anything in the browser.
No, but it would be sweet because you said like this would be useful for dApps. So then I was thinking like, you know, if a dApp is already running in a browser and at the same time is a node, then kind of you could.
What we're starting to do with dApp node is put it in the Wi-Fi system, so that if you have like an office building with a Wi-Fi router with like a shared Wi-Fi connection, or at least an office, you can just have your dApp node running with the router, and then you have a local node for everyone to pipe into. And so like you just, instead of going to mainnet Infura on MetaMask, you do custom RPC and you're connecting to your node. And what's really cool is it routes traffic automatically. So like if you go to a .eth domain in the browser, you just see what would pop up on IPFS, because it knows that there's a node right there to click to.
Yeah, and my code can run against that dApp node just as easily as it can run against a local Ethereum node on my machine or a remote machine. I'm really excited about that because what I've built, effectively what it does, it turns this Ethereum node into a usable database because it indexes it and makes it fast enough that you can build applications on top of this data.
I mean, it makes so much sense for someone who wants to have a real dApp because what you would do with the dApp node is that you would have an application that's like, hey, I want to run the Giveth dApp decentralized as a real dApp. And so the dApp devs would Dockerize their dApp, include TrueBlocks, and just kind of say, hey, these are the addresses you need to know.
Yeah.
That are like part of the Giveth dApp. And then put put that package in dApp node, if someone installs that package, when they go to giveth.eth, then they see the Giveth application really quickly, you know, because we built a real dApp, and it works.
That's right. This is like it's like a stack. It's basically a stack.
It's a beautiful stack. It's a beautiful stack,
and it works. You know, that's what's crazy about it.
Have you started? So I guess this is a dApp that you're doing like an accounting thing.
This is basically a dApp. It's one way. It only takes the data out of the chain.
Yeah.
But, you know.
Do you have? I know it's early, so I expected no. But are you thinking about building any actual like user where somebody clicks something and they add something to the chain when they're interacting with it?
You know what? I always was afraid of that because I'd lose their money. I grew up in the DAO days, so I got frightened and I was afraid I'd lose their money. But there's no reason why that couldn't work.
Yeah, well, if you connected it to a dApp that already existed, like even Remix, right? I don't know. Maybe not. Maybe Remix isn't the best thing.
Are you thinking about Web3 calls that he would kind of?
Yeah, that you could be like, hey, you know, I want to, you know, deploy this. I don't know, but basically the Web3 calls. You know, if you could run Remix as a truly decentralized app, and you could start interacting with contracts.
Yeah, it's really interesting. It's almost Mist like when you start talking like that, right?
Yeah.
Like the Mist browser was kind of, I think that was the original intent of the Mist browser.
Yeah.
What I find also like inspiring here, it could work like a dashboard for developers also, you know, when you deploy a couple of your contracts and then you want to just monitor these contracts to see.
Yeah, and you want to look at this. This is the Moloch DAO. But look at this red stuff here is an error. These are error transactions. So if you go down here, you can see that one user sent a big ton of error transactions against this contract recently. And so now you start saying, oh, well, let's go understand this thing. What is this about, right? So yeah, this is like, it could be like a dashboard. This user's probably like the administrator or something like that.
Yeah, you know, there was one guy who actually sent 100 wrapped ether to a contract that got locked there by mistake.
Is that what this is, you think?
I don't think so, because it wasn't an error. Well, I mean, it wouldn't show up as an error message. It would show up as a real message, and it's just,
it might show up here like some big dot or something.
Yeah.
So
error in which sense? Like kind of unsuccessfully finished transactions that somebody.
Yeah, this is a transaction that reverted. It wasn't a success. It was non-successful.
Yeah. Whereas this guy's transaction was successful, but it went to a contract that wasn't ready to accept wrapped ether, and so it's locked there.
Oh, I see. Yeah. So that's what we're up to. How do I stop sharing my screen? There we go.
I also have one question to the diagram with the dApps. So those are probably not meant as browser dApps, right? So you're not running a web server.
No, that's the thing though. You could run these dApps in your browser, but you would have to have some node that you're connecting to somewhere.
Yeah, I was thinking like if I would run this, what Jay just presented. I was thinking, like, I'm currently talking to some people, like from Portis. They're having a wallet, and to Wallet Connect, I think Pedro and Ligi, and I'm also talking to Austin Griffith, like Burner Wallet, and because Portis does a wallet that works not with the Wallet Connect standard, where you scan a QR code, but they're working with an iframe, but they're doing it in a way that I personally don't like, because they're showing the wallet on the dApp, so somebody could make an overlay over the wallet and suggest something false to the user, and when the user then clicks, like, let's say cancel, because it looks like that, it's a click through and it actually presses confirm or something. I mean, there's some room for attacks.
Yeah. So I would say that I don't really think of these dApps as necessarily non-browser. There's no reason why they can't be browser-based. I guess I'm just trying to point out that because in a world where every piece of software is local, it's not completely clear to me that you need a browser.
Right. No, the thing is, there is a lot of I feel I can't say for sure, but I would just from my gut would say probably 50, somewhere between 50 and 90% of people spend most of the time that they're using a desktop or a laptop in the browser, whether that's like Facebook or Amazon or Google or whatever. And they might also visit dApps, or they get links on their Facebook and they click, and they might want to use it. So of course, they could use MetaMask within Fura, but if they had like this local, like let's say this Wi-Fi router that runs something like what you just presented, then it would be cool. I don't even think that this local node, or what is it, like a TrueBlocks scraper node thing, would need to serve all kinds of websites, but just a single website that would be a wallet. And the way it would work, I mean, that's what I imagine. It's a little bit similar to Portis, but it's also not. I'm talking to all these people for a new standard. The idea is that you would have, you would sign. So the standard means that any dApp, I'm talking about browser dApps, would make you not sign in with email and password, but it would make you sign in with your URL. And that URL could be localhost, or let's say a Wi-Fi IP. And if you put it in, this Wi-Fi IP is actually your wallet. So what the dApp does, once you enter, you paste maybe your URL, it creates an iframe on that page, but the iframe is invisible. It's 0 height, 0 width. But it loads your local page, so it's sandboxed in that iframe. And then the dApp would send messages to the iframe, and the iframe opens on a new tab, if you don't have it already open, your local page. This is the wallet page, and on that one it gives you pop-ups. Do you confirm something? Somebody is requesting a transaction similar to MetaMask, and if you're on this separate browser tab that's just local host page and it's completely locked down like an online banking style system, you click confirm. This page that runs in its own browser tab sends back the message to that iframe, because they're running the same page, they can communicate. And then the iframe that is on that dApp page, but it's not visible, it's a 0 pixels width, 0 height, sends back a message to the parent window, which is the dApp. And so through this kind of communication channel, you could implement like a wallet logic. And then the wallet would be a separate web page in your browser on localhost or a Wi-Fi IP, and it would be statically served by your node, and it has all the functionality to interact, and it would confirm or cancel or like reject requests that come from an iframe embedded same version of that page, but not in 0 height, 0 width on that dApp that you load. So you could go to any a dApp that exists out there that somebody built for whatever purposes, but they allow you to, in quotations, sign in by putting in your URL, which could be a local host or whatever you want. So that's kind of the idea, to make it as secure as I can at least imagine having it in the browser. Maybe there's still some problems, but it feels to me that that should be pretty secure.
Let me just, I'll finish my presentation. I just want to bring it back to one point, okay? I think there's a very big difference between interacting with the front of the chain, where you're trying to deliver an application that's being interacted with by the user, and going back in the history of a smart contract or an address and trying to extract the data from the history of the contract. So a lot of my work is kind of on that history side, because extracting history without a third party takes 30 days to extract if you want to extract a full history of the smart contract, because of the way that the node stores its data. Now, you can do a lot of short circuiting, like you can tell it to start at block 6 million if you know that the contract didn't even exist before 6 million. But what I think QuickBlocks really brings, I'm not sure it brings a lot of benefit to the front of the chain interaction, What it brings is an ability to actually go back in the history and extract it in a usable way, in a completely decentralized way.
But that's so important for the front of the chain too, because if I have in the Giveth DApp, we want to show people who donated and when.
I know.
And we want to show all this history so that when they click the button, it's like, oh yeah, I know what I'm doing, you know?
And the thing is, if you're watching the contract from its inception, you can keep track of the state yourself. But if you're entering in later after the address has been alive for a while, you can't really do that because you can only watch ongoing from now until whenever. So going back in the history is the real problem. And that's I think what is solved by this index. And it's really a matter of just building the index, because the index gives you the access.
So basically, if you would run a node and you would want to query something, some data about the contract, it would still take like 30 days without this, or like a couple of days at least, without this layer.
It depends. If you know what you want to query, then it's relatively fast. So if you know that you want to query block 2,500,000 transaction 3, then it's pretty fast. But if you don't know which transactions you want to query, that's the problem, is finding the transactions that you want to query.
Oh, so it gives you like real time, like whatever you want to query in that moment, this layer helps you do it like almost instantly.
Yeah, and the reason that this layer does that is because it builds an index. So an index on a database is why you can query it quickly. And I think fundamentally the only thing missing from the node is an index. But I've also been talking to people and say, I don't think the node should build its own index. I don't think that's a good idea, because it already has way too much data. So adding more data is a problem. And that's why I start thinking about how can we share this index across the community so that we minimize the impact of adding this index, even though it's definitely needed.
It's amazing to me that basically, like, I think that we are not even aware, because when we say like, everything on chain is transparent and accessible.
Absolutely.
Theoretically it is, but yeah, you will need like, I don't know, 2 months,
No, I know. Well, I think that's why Griff started the open source blockchain explorer group from the beginning, is because he was trying to get a history of accounts.
Yeah. Well, yeah. I mean, I started because I just don't like the fact that I didn't like the fact that everyone had to go to Etherscan to figure out what the hell is happening on chain, right? Yeah. But to the point of Nina is like, yeah, because it's not transparent. It's some giant data blob that means nothing. Like, unless you read bytecode, it's not written for you. So you need to have a translator that can take it from bytecode to something readable, and that's a lot of work. And what Jay's done, just like being able to scan for all these addresses, is really magical.
So I want to kind of try to keep it like I was telling my friend, like what we could do is just build a layer that feeds a database, and that's all it does. It just watches and feeds a database, and then you could build applications just like you would a Web 2.0 application.
Yeah. I want to give, I mean, I think we could talk about.
I'm good. I'm good. I appreciate the time. And if anybody can think of anybody to share me with, and I'd love to talk to any people about anything. So
I think this was an amazing presentation. So I hope that you'll at least take this link and pass it around. We definitely need to tweet it and see if people are interested in building real dApps that are usable. Because I think that's what this tool provides, is the opportunity to build real dApps, really usable dApps.
Is there an API? Like something that I can from the front end connect to?
Yeah, we're working on it. It's pretty, shaky at this point, but we're starting to document it and stuff. Yeah. Yeah, there's an API.
Yeah. Hey. Well, okay. So actually, I'm really curious to hear about what's going on with Ethereum Play, because I've seen that you guys are working on it, and I guess I got the description from Nina during in her intro, but I'd love to actually see what's going on. If you guys can do a demo or.
Okay, yeah, I can show. Ooh, how do I share this? I usually don't use. Where is
It's on the left. Like if you move the mouse around, it's got like a
screen share. Okay, okay. Like share. Can you see it?
Oh yeah.
Yeah?
Yep.
Is it already visible? Okay. So basically what we built is an editor. I don't know how much you know Remix, but if you have this editor site in Remix and you write some Solidity code, you have to first compile it, and then you have to deploy it, and then somewhere below you get like a little preview, like a little form that helps you interact with this contract. And because we were inspired by CodePen, when you develop front end, you usually just copy paste or write some HTML, CSS, JavaScript, and it spits out like a nice preview. And we were thinking like, come on, this is like, it's possible. You just use the compilation metadata and you can kind of build this front end live. So whatever you change here, I don't know, it will like auto compile and it will set the, so these are the demos.
Nice.
What did I change?
You changed food.
Yeah, what did it change? Oh yeah, I was checking for the lower one, but it changed the upper one.
Yeah.
Okay, cool. So now, like for example, I can just go and publish this contract if I have MetaMask installed. What am I doing? This is crazy. MetaMask is there, but it's so slow lately. I don't know what it is.
Right.
Okay. So if I click, it should spit out the MetaMask. Let's refresh the whole thing. That's horrible. That's why I don't like to do them. Okay. So publish means deploy, but like a lot of people said, like, what is deploy even? Especially like people who are not from the ecosystem or like not developers.
Mm-hmm.
What is it? I did restart MetaMask before I started this, so I thought that it will go faster, but okay. This is always, when you're demoing, you have a feeling that time is like flying.
Yeah.
So we're publishing the simple storage contract, and then we have like two functions, set and get. And when we, did I now set some number? Was there anything? I was now a little bit nervous, so I didn't do it.
No, it doesn't have a constructor.
Okay, so we can get a number that is currently a 0, then we can set it to 97, for example. This is like a demo contract. And then you can kind of like immediately interact with it. You can also run a local node, and we hope to build also the JavaScript VM so that you don't even have to connect to any test network or anything, so that it goes way faster.
This is amazing.
Let me see, that it kind of executes this function. Okay. Okay, and then you can kind of see that now the get gives you value 97. So when you kind of write something here, it also kind of like, this is it says that it should be uint8. So if you want to write some kind of a string, it will say, no, this is not a valid entry. So you have to write some number in a certain range. So this is also too big. So you can use a slider, or you can just type the number in. And now, for example, you can take any contract. The funny thing, when he said Moloch DAO, Jay, before, I also had Moloch DAO prepared because it's so nicely advertised on the Twitterverse.
It's a nice contract. I love it has those error messages there.
Yeah.
So yeah, you can basically like copy paste any contract, and it should auto compile, and then you can actually kind of immediately interact with it. Now I would have to copy some kind of things and set all these periods. This will take now forever, but you can just publish it and try it out. Those functions, sorry?
You can break the code, maybe like some syntax mistakes, it shows all the error.
I don't know which, here, for example. Yeah, if you, I don't know, change something and it's broken, then it will try to compile and it will give you, of course, the error. So you can use it as a normal editor, of course. We're adding also the syntax highlight for Solidity, because currently we're using JavaScript syntax highlight, which is very similar. You have like all these functions that are like different colors. So you can know that these functions, for example, are view functions, which cost nothing because they are just like reading from the network. So they're free. And then in this contract, you have also non-payable functions that do change the state, but you don't send Ether with them, because with payable, you change the state and send the Ether. And this is basically the whole Moloch. So you can basically go and play with the Moloch DAO and try to publish it and create your own instance of Moloch DAO contract.
That's amazing.
Yeah.
This is amazing. It's like you built HackMD for smart contracts.
Yeah.
Yeah.
Exactly. We call it CodePen, but yeah, it can be also HackMD. Exactly. And the point is that this thingy is now like full screen, but the point is that this can be embedded. So you can kind of use your contract and you want to present like Moloch or something on your page. So you can just like embed it in the web page or something. And later, like we said, we try to now get all the list of verified contracts so that you can kind of just click around, and like we now check the Moloch, you can check any verified contract on chain.
Nina, I would really love to like participate in helping you with the collection of those smart contracts and sort of the making available of those smart contracts, because I need that information really badly for my work.
This is actually what we are now kind of working with this Igor from Scout Block Scout. Sorry, I'm so.
Yeah, Igor, the POA work, Block Scout, and like other projects, XDAI.
Yeah,
like that information should be available for everyone to use.
Exactly.
It's such important information to help people understand what's happening on these contracts.
Exactly, but the problem now is that only Etherscan has this information.
I know.
So now to get started, we will have to scrape Etherscan, but I think Igor has an idea that he would like to also include. I don't know. We have to figure out how can people verify contracts in the future so that we don't have to go always to the Etherscan. So one thing would be that maybe, I don't know, if you use this Play editor and build something here, you can already verify, or all of us can kind of offer something to verify.
Well, are you aware that Solidity, when it compiles, it puts a swarm address in the end of the bytecode?
Yes, but I know from Remix, when we were working there, that this is not stored anywhere. So maybe Remix could start.
I think that might just be a matter of default. Like the default is to not store it. And if we just simply change the default to store it.
Yes. I have to mute myself because we're in the same room with Alex, so that he can say something.
Yeah, we have just the scraper code that we have is working, and it scrapes already, and it uses a bunch of proxies to not run into rate limits for Etherscan, but it's currently storing it in the MySQL database. And as earlier mentioned by Jay, that it could be IPFS with IPNS. We are doing we want to try, next week we're meeting with like some other people because we want to try to use DAT for this. And the idea is that that would be the database. So when you want to run your own scraper node, because the code will be open source, you can either do this, but even if you don't want to run your own scraper, that maybe even includes an API so that you can later query, you could at least, in quotation marks, clone the DAT that the scraper that runs uses, so which is similar to Git. So you would clone, but the thing subscribes and gets the data. So it works like a torrent. So the database that the scraper is using is actually a torrent, and everybody who runs that can basically join and have a copy of that for the beginning. But now this is, let's see if we manage to make that work. But maybe IPFS is another alternative solution. So if you have some plans for this, maybe that could work.
You're muted.
Yeah.
That team is also less funded than IPFS, but they are like super awesome and like engaged and with the right mindset.
I don't really have any plans as far as like having done any of this. I'm just trying to imagine it. So I would be a user of that data.
Cool.
I'd love to be involved in what you're doing.
We are now like, this is the current focus, like, of the week. We started the process. It's really, that's why we were talking to Tomasz from EVM. He's also in the Telegram group, and he basically invited us to the group. So that's why you see we're like super fresh, but I'm like super thrilled that this exists. So people were saying that Ethereum happens on Telegram, but now I see that it's true.
Yeah,
it's crazy.
Yeah, so I'm very interested in that.
One day we'll move everyone to Gitter. One day.
Yeah. I mean, it's easy because it's a nice phone app and stuff. I don't know.
Yeah, exactly. It's just too easy.
Yeah, I know.
But yeah, well, guys, dude, thank you guys. This was an amazing demo day. Like TrueBlocks with the fresh UI and Ethereum Play. I mean, Ethereum Play just seems like the perfect development tool. I mean, really, you guys have outdone yourself. I can't believe you made something that might even be more powerful than Remix. I mean, for a different application, but like seriously, to be able to just see what you're doing when you're coding Solidity, like that's wild, you know?
Yeah, it still lacks a lot of the advanced features from Remix, like on purpose, but I don't know, that's like what we wanted to reduce it, but I don't know.
If you want to ship, you got to cut scope. I mean, come on.
Yeah, right.
So how long have you guys been working on that?
5 months.
Yeah, but like we also had the other, so maybe just on the editor, 1, 2, maybe, yeah. Not so much, it's fresh.
And is it just you guys, or do you have like a community people can join or anything?
I mean, it's all open source. We are on GitHub, so everybody could join and help us. We have a lot of tasks. All our roadmaps the whole roadmap is on GitHub. We have 2 people that we work with that are based in Taiwan. But yeah, the budget that we have is actually just for us too. So we're just sharing a bit, and they help us a little bit. But it's a very, very small team.
That's amazing. And what about you, Jay? Do you have any community? Like, where do you and Wild Molasses hang out and chat about TrueBlocks?
We're shifting away from Slack to Telegram just this week. So our community is pretty small at this point. Not sure why. I'm too heads down. I'm too in the command line. I'm not looking up and doing community, but I should do more of it.
It's both of them are amazing tools, guys. And if I'm sure, how do people best reach out to you guys?
Through our GitHub, probably our GitHub, or through the website. Our website, quickblocks.io.
Okay.
Yeah, and we are play.ethereum.org. So there are all the important links to repo and to the editor itself. And also Twitter, I'm Nina Bresnik, and Alex is at Saraplat. So if someone wants to connect.
We also have a Gitter chat, and maybe one thing with Gitter, I'm not sure if it's so known, but there is an irc.gitter.im server, so you could, if you have a terminal client for IRC, you could connect to Gitter also through IRC. I mean, if this kind of makes sense for anyone, I don't know. I think it's not so known.
Yeah. Well,
I'll try it out.
Yeah, and I guess I might as well let Alexi from Fluence say if people want to reach out to Fluence.
Yeah, if you want to reach out to Fluence and know how to, for example, make a decentralized database real and make a real G app like with QuickBlocks too, you can reach us to Twitter. Let me. Yeah, it's Fluence here. Fluence Labs. Yep, and we also have a Telegram chat, which is Fluence N, and you can reach out for us there. Yeah, and I maybe I'm a bit late, but I would like to chat sometime with Thomas about storing his index decentralized in Fluence, so it could be done. What could be done is index IPFS data in Fluence and search it quickly.
Great.
That would be super cool.
Maybe you'll give us a demo one day.
Yeah.
Yeah. I think that's a great idea.
Yeah.
Yeah. Come on back and let's do another demo day. Okay, well, thank you guys. We went long, but it was just too good to stop. So thank you guys so much, and I'll see you guys in a couple weeks.
Thank you. Take care.
Bye, guys.
Bye-bye.